Hello, welcome to another A-Level Maths video. This is a Pure Maths Year 1 video where we're looking at Chapter 2, looking at Section 2.6 of the textbook, and we're going to start to introduce ourselves to the idea of mathematical modelling. So what's a mathematical model? Well, there's a definition on the screen. A mathematical model is a mathematical description of a real-life situation. In other words, it's where we try and get a formula or an equation which helps us understand some kind of real-life situation. Sometimes the models can be very complicated, and other times they can be very simple. Sometimes they can match reality very, very closely, other times not so much. But whatever we do, hopefully it's a useful thing for us to do, and we do understand, the limitations of doing it. So in this particular section of the textbook, we're really just going to look at models which involve quadratic functions here. And I've put an example on the screen here. We've got Robin throwing a stone off a bridge into a river. And we are modeling the height of the stone, h, above the river, and in terms of the time in seconds after Robin released the stone with the formula you can see there. Okay, so why don't you see if you can make sense of this already? I've put a couple of questions on the screen about this particular mathematical model, about the stone throwing. Can you pause the video in a second, have a go at the questions, and restart once you're done? Okay, let's see how we're getting on with this then. So here's our model. The height of the stone, h, is given by this formula here, minus 5t squared plus 10t plus 15. And we'll see if we can work out what the initial height of the stone was at the instant that Robin released it. So the first thing to answer for that is, what is the value of t when Robin released the stone? Well, we're told in the question that t is the time in seconds after Robin released the stone. So of course, no time has happened at the instant that he does release it, and so t must equal 0 there. Okay, so substituting that in, we end up with minus 5 times 0 squared plus 10 times 0 plus 15 is our value for h. So therefore, at the instant that the stone is released, h must be 15, and so Robin must have released it at a height of 15 meters above the river. Okay, making sense so far? Here's another one for you to think about. Here's a different situation, but again, it's a quadratic formula which is modeling. In this particular case, the depth of a diver below sea level when the diver, is diving in the sea. Again, pause the video, have a go at the questions, and restart when you're done. Okay, so here's our formula. The depth in meters is given by this formula here, or at least it's being modeled by this formula here, 10t minus a half t squared. T, again, is the time in seconds after the dive starts. So the question we had, first of all, what would be the value of d when the diver is at sea level? Well, what does the question say? D is the depth below sea level. So at sea level, we must be 0 meters below sea level, or 0 meters away from sea level. So therefore, d would be equal to 0 at sea level. According to the model, determine the times when the diver is at sea level. Well, then we just need to substitute 0 for d into our formula here and solve the equation that we've got here. Now, I think the easiest way to solve this one is by factorizing. So I'll just factorize out the t. We end up with 10 minus a half t in the bracket there. And I think that's telling us that we're going to have t equals 0 is one solution from this factor here. And then if we set 10 minus a half t equals 0 there, that's going to lead us to a value of t of 20, I think. So the diver must be at sea level at the start of the dive, times 0, but also 20 seconds, the diver must have returned back to sea level again. Right, let's get a little bit more complicated now, shall we? Here's another quadratic model. This one is to do with money. A company making bracelets, they want to have as much profit as they can. They've come up with a mathematical model which describes how much profit they're going to make based on the selling price of the bracelets. And they want to know what selling price they want to set so that the profit is the most. Okay, so pause the video. It's going to lead you through it a little bit. Have a go at it and see if you can work through this one yourself. Okay, let's see how we got on with this one. So another use of completing the square here, but this time in modeling this real life situation. So hopefully you noticed in the first part of this question that basically you're trying to do this in completed square form. I'm just going to quickly go through the process here. We've got a coefficient in the x squared here, so we need to factorize that out of those first two terms. And I think we're going to end up with that there. Okay, inside the bracket here, we now need to do the completing the square on that. So we're going to have this coefficient of x here, which is -8. Divide that by 2. That's what the number that goes inside here. And then subtract away from that the square of the number we've just written down. So the square of -4 is +16. Subtract away +16. The -24 is still here. And then let's just expand out the bracket. So -2 times the x minus 4 all squared. -2 times -16 is +32. -24 still there. And then finally, we can just collect these terms together and we end up with the answer that's given there like that. Okay, so this is our formula here for P in completed square form. Now, we've been asked to use this formula to determine the company's maximum possible profit. So do you remember how we get maximums from completed square form? It's because of the idea of the squared term here. The smallest that can be is 0. So when that is 0, the value of P here is going to be at its most extreme. And in this case, it'll be a maximum because we've got this negative coefficient here. So the maximum profit is going to equal 8 here. So the maximum value of P is 8. So the profit here, the maximum profit is £8,000. Yes, because we're told that P is measured in thousands of pounds. What's the value of x which gives us that maximum? Well, it's the value of x which makes this bracket here equal to 0. So that would happen when x equals 4. So the selling price for the bracelet that we want is £4. That's going to be the best selling price, which is going to give us the biggest possible profit of £8,000. Okay, so just a few examples there of modeling with quadratic functions. Modeling is going to be a very, very important thing as we go through the course. We need to make sure that we are familiar with the ideas of modeling and that we can relate these real life situations to the models and vice versa. Okay, but that's it for this video. Please do get more practice by looking at exercise 2H. But that's the end of the chapter, and I'll see you next time for chapter 3.